Identify the electrode at which oxidation is occurring. Explain your reasoning based on the student's observations. Since the SN electrode is losing mass, SN atoms must be forming SN2+. This process is oxidation. Or, because the cell operates, E standard must be positive, and, based on the E standard values from the table, it must be SN that is oxidized. 1 point is earned for the correct answer with justification. As the mass of the SN electrode decreases, where does the mass go? The atoms on the SN electrode are going into the solution as SN2+ ions. 1 point is earned for the correct answer. In the expanded view of the center portion of the salt bridge shown in the diagram below, draw and label a particle view of what occurs in the salt bridge as the cell begins to operate. Omit solvent molecules and use arrows to show the movement of particles. Visual. The response should show at least one K+ ion moving toward the Cu compartment on the left and at least one NO3- ion moving in the opposite direction. 1 point is earned for correct representation of both K+ and NO3- ions. Including free electrons loses this point. 1 point is earned for correctly indicating the direction of movement of both ions. A nonstandard cell is made by replacing the 1.0 molar solutions of Cu NO32 and SN NO3 2 in the standard cell with 0.50 molar solutions of Cu NO32 and SN NO3 2. The volumes of solutions in the nonstandard cell are identical to those in the standard cell. 1. Is the cell potential of the nonstandard cell greater than, less than, or equal to the cell potential of the standard cell? Justify your answer. 2. Both the standard and non-standard cells can be used to power an electronic device. Would the non-standard cell power the device for the same time, a longer time, or a shorter time as compared with the standard cell? Justify your answer. It is the same. In the cell reaction Q equals SN2+ / Cu2+, and the concentrations of SN2+ and Cu2+ are equal to each other in both cases. 1 point is earned for the correct answer with justification. The non-standard cell would power the device for a shorter time because the supply of Cu2+ ions will be exhausted more quickly. Or, the non-standard cell would power the device for a shorter time because the reaction will reach E equals 0 more quickly. 1 point is earned for the correct answer with justification. In another experiment, the student places a new SN electrode into a fresh solution of 1.0 molar Cu NO32. Visual. 1. Using information from the table above, write a net ionic equation for the reaction between the SN electrode and the Cu NO32 solution that would be thermodynamically favorable. Justify that the reaction is thermodynamically favorable. 2. Calculate the value of dG standard for the reaction. Include units with your answer. Cu2 plus SN gives Cu plus SN2 plus. E standard is positive, 0.34 V plus 0.14 V equals 0.48 V. Therefore, the reaction is thermodynamically favorable. Or, the cell observations from earlier parts of the question are evidence that the SN is oxidized and Cu is reduced. Therefore, E standard must be positive. 1 point is earned for the correct net ionic equation. 1 point is earned for a correct justification. dG standard equals minus NFE standard. dG standard equals minus 2 moles E minus 96,485 C / moles E minus 0.48 J / C equals minus 93,000 joules per mole RXN equals minus 93 kilojoules per mole of reaction. 1 point is earned for the correct number of electrons. 1 point is earned for the correct answer with unit.